First, I would like to introduce our project. A beam in building construction is a horizontal part that spans an opening and supports a load, which may be a brick or stone wall above the entrance. In this instance, the beam is frequently referred to as a lintel. A curved beam is described as a beam with a curved neutral axis in the unloaded state as opposed to a straight one. The curvature of this beam introduces unique mechanical behavior and design consideration. The neutral axis is pushed toward the center of curvature in curved beam too. Moreover, the stress distribution in curved beam is hyperbolic. Curved beam experience both bending and shear stress due to the varying radius of curvature along their length.
The curved beams that are also called arcs in certain fields are well established due to more load that can be transferred through the combined action of stretching and bending. Curved beams are more efficient than a normal straight beams, but by comparing their analysis, curved beams are more complex due to bending, stretching, coupling. The stress deformation effect and rotatory inertia increase their complexity. The different type of curved beam also have different applications in construction field that will be introduced in the behind part.
Now, I'm going to introduce the first type of beam, which is curved glulam beam. It consists of layers of dimensional lumber that have been joined using strong moisture-resistant structural adhesive so that all of the grain line parallel to the longitudinal axis. The first step to manufacture curved glulam beam is drying and grading the lumber. The lumber may be dried in on-site lumber kilns or purchased pre-dried from suppliers. The moisture content of the lumber can be determined by a hand-held moisture meter, and the moisture content of the lumber must be between 8% to 14%. The second step is end-jointing the lumber. The finger joint is the most common end joint for lamination. Both ends of timber were applied with resin adhesive before curved under and pressure. The adhesive durability tests are then repeated at end joints to evaluate their resistance to delamination. The third step is fixed gluing the lamination. Laminations for curved beams are glued with adhesive such as phenol, resorcinol, and curved in desired curve forms or shapes. The thickness of the laminations determines the degree of curvature in glulam. The last step is finishing and fabrication. The timber is brought into close contact with the straight beams using a mechanical or hydraulic mechanism in a clamping bed to form a unique layout pattern. And remember, the glulam beams must cure for 5 to 16 hours at room temperature.
For the second curved beam is curved concrete beam. Concrete beam is a load-bearing component that may support both horizontal and vertical loads in structural engineering. These beams are constructed by encasing steel bars, plates, or fiber within the concrete and are known as reinforced concrete beams or reinforced cement concrete beams. Concrete beam would be brittle and breaks under the loads applied on it without the steel reinforcement. Precast concrete beams are frequently used in bridge construction. These beams are created by extending tendons made of high-strength steel, engaging them in concrete, and releasing the tendons once the concrete has started to harden. It results in less waste space and a more compact design.
In the part application, vertically curved beam involve arch and wall structures. An arch is a vertical structure built using wedge-shaped components such as bricks and stones and are connected together with mortar. These individual units are also known as voisors. They are positioned side by side with the upper edge wider than the lower edge. When downward pressure is applied to the arch, it causes the voisors to push together instead of apart. The central voisor in the arch is known as the keystone. In arch structures, curved concrete beams are designed to resist both compressive and tensile force and can be cast in various shapes and sizes to suit the specific arch design. Besides, curved steel beams are commonly employed due to their exceptional strength and flexibility, offering excellent load-bearing capacity. Furthermore, curved glulam beams were traditionally used to provide structural strength and can be shaped and joined together to create curved arch forms. In conclusion, there are various types of arch structures such as triangular arch, round arch, segmental arch, and lancet arch.
Now, I would like to talk about pedestrian walkway and bridge. Pedestrian walkway and bridge play an important role in urban and suburban environments. It provides dedicated walking area for pedestrians away from car traffic. This separation improves safety by reducing the likelihood of accident and conflict between pedestrian and car. Besides, the pedestrian walkway and bridge allow people to travel on foot, increasing accessibility and mobility in urban and suburban environment. They provide pedestrians with a quick and easy way to get from one area to another, including park, workplace, and school. Besides, the pedestrian walkway and bridge can encourage pedestrians to travel on foot as a strategy to increase sustainability and reduce greenhouse gas emission. This results in reduced motor vehicle use on short trips, thereby reducing air pollution and congestion. The curved beam was used in a wide range of civil structures, such as to construct the pedestrian walkway because the curved geometry can reduce the bending moments and provide additional strength to make the bridge supply more efficient load transfer than their straight or flat counterpart. This can result in lighter structural element and cost saving in terms of material and construction. The curved beam also provides design freedom, enabling unique shapes and configuration to satisfy the specific project needs, and also to create original and innovative design that fit the site environment. The pedestrian walkway and bridge are investigated for its safety, comfort, and accessibility to achieve high walkability. The walkability of the pedestrian walkway and bridge is important because it indicates the building environment whether it's suitable to walk or not. The pedestrian walkway and bridge should satisfy the characteristics such as lightweight, high resistance to corrosion, and easy maintenance.
In this project, we have discussed the arch structure and pedestrian walkway and bridge. One of the famous examples of arch structure is Colosseum, which is located in Italy. Arch structure played a crucial role in the construction of the Colosseum, contributing to its unique character. It is recorded as the largest amphitheater ever constructed in ancient times and continues to hold the distinction of being the largest surviving amphitheater worldwide. The Colosseum stands independently as a structure, drawing its external and internal architectural design from the combination of two details placed back to back. Arches have a higher load-bearing capacity compared to horizontal beams. This capacity arises from the fact that when pressure is applied downward on an arch, it forces the walls together instead of pushing them apart. Next, the other example of the pedestrian walkway and bridge is Kingsway Pedestrian Bridge, which is located in the Burnaby, Canada. The Kingsway Pedestrian Bridge, spanning 44 meters over one of the Burnaby's main roads, was strategically designed to become a prominent feature in the growing community. It provided a vital link between a major shopping complex and the expanding commercial and residential areas to the north. The Kingsway Pedestrian Bridge is known for its unique design, being the first overpass to incorporate a timber drop-in span supported by steel branches connected by a post-tensioned concrete platform. The bridge's design has garnered positive feedback for its elegant structure that spans Kingsway streets and creates an inviting and usually appealing entrance for both visitors and locals in Burnaby.
Next, we are going to the recommendation. The first recommendation for this report is design consideration. The buyers should work closely with architects and engineers during the design phase to determine the required curvature, dimension, and load-bearing capacity of the curved glulam beam, ensure that the design complies with applicable building codes and standards. Next, material selection. Use high-quality and properly graded lumbers for the lamination. The species, grade, and moisture content of the lumber should be carefully selected to meet the design requirements and environmental conditions. Follow recognized industry standards and guidelines for selecting and grading the lumber.
Conclusion: curved beams have been applied in various architectural and structural engineering projects, especially in civil engineering field. There are two types of curved beam mentioned in our group project, which are curved glulam beam and curved concrete beam. For curved glulam beam, also known as curved glue laminate beam, is a structural element made by bonding together layers of wood veneer or solid wood member in curved shape. Curved glulam beams are resistant to decay, insect, and another environment element. This ensures their longevity and reduce maintenance requirements. Curved glulam beams also become an environmentally friendly option because they are made from renewable wood resources. For curved concrete beam, it's a structural element with curved profile made of reinforced concrete. It can be created using several techniques, including formwork, precasting, and specialized bending method. Curved concrete beam also provide higher load carrying capacity than straight beam of the same material and section. Besides, it helps to distribute load more efficient, reducing stress concentration and improving overall structural performance.